Hello fellas and extraordinary engineers. Let me first introduce you to our beloved team, Spirit. We're a group of enthusiasts, Zewail City of Science and Technology students from 3 different engineering majors. The team is subdivided into 3 sub-teams. Mechanical, which is responsible for the main chassis and body design and the manufacture. The electrical sub-team, which is responsible for the wiring and programming, the main functions and electronics of the robot. And finally, the mapping and control team, which receives the output of the sensors and manipulate it to map the pose, velocity and angle of the robot, along with the mines found in the field.
I am Hazem Al-Rifai, a member in the mechanical team. Basically, our design is divided into 3 parts: chassis, body, and arms. The chassis is made of 2 mm L-beams of aluminium. We choose aluminium because it is light and steady. An arrangement similar to the letter H provided us with extra space for the electronic components. The chassis is connected to 4 plastic wheels with grooves which are designed to accommodate different types of land. Then, the body is a simple design made of acrylic, designed to protect the electronic components inside. There will be also 2 fans in the body to resist the increase in temperature inside the robot. Finally, the arms are made of wood. Each arm is divided into 2 parts, vertical part and horizontal part. This design will provide stability and decrease the vibrations in the arm.
Greetings, I'm Omar Yasser. I'm going to talk about some of the components we are going to use in our robot. To detect metal objects, we are going to use 2 metal sensors, one on each side of our robot. To help us with mapping, we are going to use a rotary encoder to calculate the distance moved by our robot from the rotation of the wheels. To help us with control, we are going to use Arduino Mega to get information from some components and to give signals to the others.
For the manual control of our robot, we wrote a LabVIEW code whose inputs are the directions from either the PC's keyboard or a joystick and the required speed level for the robot. It then communicates those pieces of information with an Arduino on board of our robot through a communication module. The Arduino in turn determines the required voltage together with its polarity that will be assigned to each of the motors on each of the wheels. But it's not just all manual. We're working on a separate system for an autonomous control of our vehicle. We aim at using a PID controller whose input values are dependent on the parameters we obtain from a mechanical model we're going to construct using Simulink. The output values are then fed to our Arduino code. For the mapping, LabVIEW was again used to provide a user-friendly interface of a map that not only displays the robot's real-time position on the field, but also marks whenever any of the metal sensors detects either an overground or an underground mine. The robot's position is determined with the help of a 1000 pulse per revolution encoder that, together with an IMU, allows for a great accuracy.